So now this was the first version of our code. And then in the next version, we are using those subroutines a little bit different way. So my next example is with the pointer. So it's a pointer to the memory location. So it's the same in the beginning. So you can copy from the earlier code that it's include embed H, digital out, let yellow, let green, let red. We have the same treat names here, treat 2, treat 3. And then, okay, the counter here is a new one. I'll just, oh yes, I will show you that it is possible to stop a treat as well. So I'm counting their seconds or execution of the main loop and then stopping one of the treats in a certain count value. So that's why there is a counter. So integer counter that will be used in the end, in the main, I'm just increasing the counter there in the while loop. And if the counter is greater than 20, treat to terminate. I'm using the counter for terminating one of the treats. Anyway, then the subroutine is different. So I call it let any. So this is for any of the LEDs. I could have 10, 15 LEDs there and then just use a pointer to point out to a certain LED. So from the programming in language C or C++, someone might know that that's a pointer. So when I establish an variable, I actually create their variable in a certain memory location, and then I can point to that memory location. So in this subroutine definition, I'm defining the digital out, let A, and the pointer for that one. And then there is a while loop. So now in this is my let any. Let A, in that memory location, I'll write value 1. And then wait for 500 milliseconds. And in that memory location, write there value 0. So I'm blinking, okay. Wait 1500 milliseconds. And then printing the pointer value so that I know that where in the microcontroller memory is my LED. So I'm using the printf method. That's the standard C++ printf. So the characters in here. So, and this is defining that there is a variable and the %b, what is that? We can have a look on the that was the easier to read reference for the C++ and the printf. And then there are these specifiers, and you can specify that the variable is a signed decimal integer, unsigned decimal integer, and so on. Up to you look for this list and you get to the pointer address. We have a specific specifier for pointer address. Okay, then I'm using that one. Should work. So I'm printing here the pointer address of the pointer let A. And then this is just for the next line. And then now I have only one subroutine. And in the main program, before starting this while loop, I'm starting these two treats, treat 2 and treat 3. So treat 2 start with the callback. I'm starting the let any. And I can give there also the parameter like this. This is a bit odd. I don't know why it is not written like this, that I'm calling the let any with the parameter at let yellow. This at let yellow is reading the let yellow address. The let yellow is a D3, so it is taking actually this hardware address of this D3, digital out tree. I think I have an opinion. Why doesn't this work? Because I'm calling this let any with the parameter, but it's not compiling correctly. So the writing is that you put there, write it like this. Right. So then I wait for 1000 milliseconds and start another thread. The thread 3 start, callback, let any, and this time I give a parameter at let green. So I have started the same subroutine in 2 different threads with different parameters. So now you can complete the code up to this far, and then we go down to the while loop and what is there. So what is here in the while loop? So this is simple again. So it's only, I have the counter, which I defined as an integer in the beginning. I'm writing there, this is the same as in the earlier example. So I'm blinking my LED. So let write 1, this thread sleep for 500 milliseconds. Let write 0, this thread sleep for 500 milliseconds. And then I'm testing with the counter. When this counter has counted up to over 20, it will terminate the other thread. And that's it. So I will copy the whole code and put it on a notepad window so easily see the whole thing at the one. Yeah. So it's there. So now you need to compare. Finally, when you have this compiled and loaded to the microcontroller, you need to compare this operation of the LEDs to the earlier example. And then the point is that both of the green and yellow are using the same the same subroutine is used for both. So both are blinking with the same rate. So 500 milliseconds on, 1500 milliseconds off. But I have called those at a different time. So first calling with the yellow parameter, and then waiting for 1 second and calling with the green parameter. Just have a look at what is the difference in the operation. Any questions on this?